man, this is really living.
We're committed to the art and nothing can stop us. Not even a train, plane, tractor, all of us as we feel the rhythm inside the marrow of our bones.
Hey guys, Kool-Aid here. I'm going to give you a video. I know I've been putting out quite a few videos, but there's been some good activity going on, guys. Well, I'm going to show you right now. Actually, I was fairly surprised that this happened, and you'll understand when I get to the end of this. I wasn't surprised that we've seen this object right here, because this is exactly where we'd expect it to be. Okay, this is something that Scott caught over on Lasco C2. Okay, the seed side, I believe, is the chronograph. I don't know if this one was a chronograph. It might have been. It was either that or just a regular C2 imaging. But he ran it through some filters, and just to draw that out a little bit more. Now, he said in a live stream about a week ago that we should catch this thing, if we were going to catch it again, between the 12th and the 15th. And he said that it would be in this position. And it is. So, I want to make it clear that, that I actually, I do believe this. This is what I think is actually going on. Okay? I think it's in a 28-day orbit. That's, and the reason why is because there's been so many observational evidences of this now that it's hard to deny it. It's hard to deny that, when we can say, mainly Scott, because he knows he's got the timing down on this perfect, at least, close enough to where he can say, hey, it's going to be in this general area, okay? He's able to predict where this thing's going to be. So when you can do that to an object that they don't even let everybody know that's there, it's totally valid. It's hard to deny it. So that's what I'm trying to say, guys. And that's where I stand. Now, if you guys have other opinions, it's all good. I'm serious. If we all had the same opinion, we never would learn anything, right? Or at least go for something different or new. But at the same time, we have to be real. So, when we do see these observational evidences and predictive capabilities of where this thing's going to be, I mean, you don't need much more to, say, hey, the chances of this actually being true are greater than the chances of it not. Okay, that's at the very least that you could say. For me, I actually think this is what's going on through my own research. That Scott pointed, he's like, hey, this and this and this. He told me about his 28-day orbit well before he came out with it. Okay. And I went on my own. He didn't ask me to do it or nothing. I just went on my own because I was curious myself. And I found in a 28-day cycle, if you back up, you'll see reactions where they're supposed to be reacting according to where this object would be. There's sightings of it. Okay, there's captures of it, I should say, of where that should be on a 28-day cycle. Months in a row. Okay? So with that, that's all. It pretty much convinced me at that point. But we're still getting captures now. So I mean, and it's right where it should be, according to the theory, the 28-day orbit theory. Okay, so that's where I'm at with that. But this right here, guys, this is the object. Okay, now I'm gonna go ahead and run you through some pictures here. He did all these. He ran it through his 4K filters. Yeah. And something else he mentioned, it looks as if this thing might be glowing. That's the first time he's ever said something like that about this particular object. I don't know if he's completely sure that that's what's going on yet, but that's something he's, throwing out there, that it may be, these stellar core objects. If you guys research anything about cores, they can regenerate. And if they do that, they would start emitting light again. Okay? So, we'll leave it at that, but, I guess, there's pretty much no, hardcore evidence that that's what's going on, okay? It's just something that he's, putting out there for this because if you look at this, it looks as if it might be glowing. Now that could be coming off the sun or what have you, but it looks as if it, you know, itself, it may be putting off some light, okay? But then I see this. Okay, this happened. I can't even believe it. My chin is still on the floor. I mean, honestly, I mean, wow. I just don't even, it's hard for me to even think that this actually happened like this, because this is not the same object. Okay? We've caught 3 of them before in the same general vicinity. Okay? This is a second object. This is not the main object, and I'm going to show you what I mean. Okay, now, obviously, that's, you know, you don't get much more spherical than that. I mean, that's, and that's, that right there, that filter I did right there, is almost like the original. And I'll show you the original, because it popped out like a, I mean, I didn't even have to do nothing to it. It was just there. Just like this, okay? Scott didn't have to do much to that. It was just there. It's not hard to see now is what I'm trying to say, guys. When it shows up, it shows up. It's there. Okay? Now, there are times we got to run some filters and stuff to draw certain things out. And that's, you know, it's just normal stuff. But anyway, there's the other filter I put it in. I mean, look at that. That is, it's almost a perfect sphere. Okay? So, you know, I was trying to, after I seen this object just a few minutes ago, I started running it through my filters and doing all the things that I do. And I wanted to make sure that this was not the main object. Okay? I kind of knew that it wasn't, because just visually, just looking at it this way, it looks smaller. Okay? And that makes sense, because the main object should be bigger than the ones that are surrounding it. Okay? So, okay, I'm going to show you the originals. Look at this. This came, that came straight up off of Seeds. There is no filter on that whatsoever. All I did was add the text there. Okay? You know, not that I needed to put that many arrows around it, but it's there. Okay? So I wanted to, you know, and there it is. Okay? Now, so what did I do to kind of try to rule out that it wasn't the same object that had just moved a little bit over or what have you? What I did was, where'd they go? Oh, there they are. Okay. Sorry about that, guys. First thing I did was I made a comparison. Okay? I tried to basically match the size of the occulter here from top to bottom, and then I just visually looked at it. Okay, you can see just by looking at this one that two things here. This is closer to the sun at this particular time frame. This is off further to the left. Okay, and this object down here at the bottom is clearly smaller than the object at the top. Okay, so what I think is going on here, this is just my opinion, I could be wrong as far as the location of this, but if I'm correct in what I'm saying, the main object, I'm just going to draw out here in the middle here, so here would be the main object. The secondary object would be kind of like this, but it would be behind it. Okay, kind of at an angle going that direction from the main object. You guys understand that? Now, and then the next thing I did was I put it in some overlay software, and I started to, my overlay software wouldn't let me turn it into landscape mode for some reason. I was going to have to do it. I was going to show you as I was doing it by moving the slide bar, the opaque intensity that you can do. In other words, you can have the picture fade in and out that's on top. But it wouldn't let me put it in landscape mode, so I had to do it in vertical. But so what I did was I just took some screenshots. Okay, I started at one end to work my way to the other, and we will start right here. Okay, this is the original photo from, or the capture that Scott made earlier. Okay, and this is where I started putting the overlays. Okay, you can see Bigger object, smaller object. Okay. Oops. Here's the bigger object. These are just two pictures laid on top of each other, guys. Okay? That's all that this is. Alright, here's the bigger object, and here's the smaller one. Okay? So, then I went over to the next one. Actually, I think I might have zoomed in up here. Let's try these up here. I think I did. Yep, there we go. Okay, this one kind of shows it pretty good. You can see the smaller one here, and then the bigger one would be here. Right? Okay, so then I started fading out the main pick, and you're going to see the second object start being more prevalent. Okay, so what I'm saying is that those are two different size objects in two different positions. Okay, so how did we catch the second one, right? Well, what I'm going to do is let's do this first real quick. This one kind of shows it really well. If you guys can just kind of have a little bit of imagination here a little bit, I'll zoom in as far as I can. But if you look at the distance between the occulter, because these occulters are the same size. I made them the same size. I put that blue sun there just so we would have a reference. Okay. Now, the distance from here to here is greater than from here to here. See, this object is actually even touching the occulter. It's in the view of the occulter. Okay, so you can clearly see that those are in two different positions and they're two different sizes. So those are two different objects. Okay, now with that being said, like I said, I'm going to take you guys over here to seeds. And we're going to look to where I seen that when I caught it. Okay, that second object anyway. And we'll take a look at that, you know, what most of us would call CME, which it really wasn't. They're just reactions with these objects. It's not a true CME because it wasn't exploding out. Okay, I was even thinking it was a CME, and then after listening to Scott, he kind of explained it to everybody, and I'm like, yeah, it makes sense, you know. So what I'm saying is, this was not a true CME. This was these objects interacting with the sun. Okay, so obviously the first right there. Well, I'll tell you what. Let's just take it frame by frame here. We'll just do it that way so I can show you what I'm talking about. All right, now here's when it first reacted with the sun. Okay, so with that being said, let's go further. Now you can see how that thing just lit up, man. That object was there. It's hardcore there, right? So there was that first initial reaction. Now watch this. The second object causes the sun to react too. Okay, because you're going to see it, because this tool's going to think it's a CME, because you're going to see the blue and red lines. Okay, see them show up right there? Now watch as this thing passes. Watch this energy go over top of this object, react with it, and then go on off into space. Okay, you can see it starting to show up right in here. There it is. Okay, I'm going to back it up. See? So that was the second reaction, and that second object showed up, guys. Yeah. So there's two objects. We caught two objects this time around, guys. It's pretty cool. You know, and I think that this is why we're getting these funky readings on the magnetopause that we have no explanation for, other than cosmic rays. I mean, they can't all be cosmic rays, guys. They just can't. Some of it is because we are getting increased cosmic rays. But I showed you guys yesterday multiple times that it's kind of funny that our magnetopause and magnetosphere started reacting at the same time this object reacted with the sun. Does anybody else think that that's kind of funny? I do. I think it's extremely suspect. Because we're talking about, the energy traveling, magnetically here, guys. Not just, with what they would consider a true solar wind. Alright, because that would take 2 to 3 days, sometimes 4 to get here. But if it's going to travel the magnetic route, it can travel much, much faster. Okay? So that's my point. So that first reaction, when we caught the initial object right here, okay, that's about the time the magnetopause started jacking up. It was like an hour or so later, okay, then it started jacking up. I mean, and I showed you guys a lot of those models already, but yeah, guys, so I don't know what else to say about this, because that definitely, most certainly, in my opinion, is a second object. It's not the same object. Okay? I'll just take you guys back over here. I'll show you this. I'll put this picture back up while we talk. Bigger one. Yep. Now, see, I ran this through a filter, too. See how that drew that out? All it did, I mean, it's a really light filter at that. I mean, it's not a whole lot done. Just some brightness and contrast taken out. Okay? So it just let whatever was there just shine. And, obviously, this is an awesome capture. The definition of what Scott can do is so much better than what I can with my software. But hopefully, maybe Scott will grab some of these captures and convert them up. And we'll see what we got, I really think that this is, like I said, a second object. So, in other words, this is kind of confirming what we're talking about. We caught 3 objects before. We know it's a system. It's not just one object. And it would make sense that the second object would be smaller than the main. Okay? So that's where I'm going with this. There's always, like I said, I could be wrong. But when I'm looking at something like that, and like that, it's hard to deny that that's something other than what I'm saying it is. At least at the very minimum, the shape of it. I mean, and then you can start talking about what looked like a CME. Hardly any of us have ever seen CMEs take that kind of a shape and react the way that it is. And here's something else. I'll tell you what I'm going to do. I'm going to take you guys over to SDO real quick, too, because this actually helps show that it wasn't a big, violent, like, blast from the sun, which would be a CME. This came off very, very slow and soft. Okay, and there's evidence of it because that was actually moving kind of slow. All right, as it came off the sun. You could tell on the seeds captures there. But what we'll do is we will go, let's go back to the 12th. About 1 o'clock there, doesn't really matter. As long as we get what we need in there. Let's go to the 13th. Well, let's just try the 14th, if it'll let us go to the 14th. See how long it'll let us see. Okay. And we're on the 171 angstrom because that really shows this, what I'm trying to show you guys, really, really well. Okay. Now, there's a whole lot of stuff here that really points to this being an object. Okay. I have never, ever. Okay, now when I'm going to say this. When we get a filament that releases, it like fling, man. I mean, it blasts off, man. I mean, it is rough and tough. It goes, right? That's, if it was a CME, that's what we would expect to see. Now, I'm not saying that we haven't had slower CMEs come off the sun less violent. That's not what I'm saying. But what I am saying is that the way that this one here reacted, in the direction that it took, and the movements that it made after leaving the sun, is very, very suspect, and it goes in the same direction of these objects. Okay, so I'm going to zoom in here, and we're going to take a closer look at this. Obviously, guys, you can see when it starts here, and I already talked about this in a previous video, but you see it right here, and it's going to take a dive south. See that? And then, remember I said I showed you that secondary eruption, or what I'm calling an eruption is just the reaction with that second object. Okay, here, this is going for the first one. Then the second, you'll see a little secondary burst about right there. Boom, see that? That was when it reacted the second time with that other object. Okay? That, at least in my opinion, that's what it looks like to me. And again, see how far down that's taken a dive? What would make energy from the sun do that? Well, another object would. Another magnetic field, right? Something reacting with the sun. Okay? Now, I want you guys to take special note here on how slow this thing is moving. Okay, that's really, really slow, guys. It really is. I've not seen a CME ever do that slow. Now, I got a comparison I can show you. Okay, on the same sun picture. Same time frame. If you look over here, you're going to see a little eruption. And watch what it does when it lets go. Okay? It's getting ready to do it, I think. If I'm in the right time frame here. Come on, don't make a liar of me here. Am I not in the right position? Well, I showed it to you guys in my previous video. I may have to go back further. I think I do. I don't think I'm back far enough to show you when that one did happen. But it flung. I mean, it was really fast. Okay? It looked like somebody, you know, when you were a kid or whatever, or even as an adult, being at the swimming pool or getting out of the shower, messing with your kids or your spouse or whatever, and you take a towel, a wet towel, and you twirl it. And you reach out and you snap it right on their butt, right? That's kind of what this would look like. That's typically what a CME looks like. It looks like a towel that's getting snapped right off of the sun. This looks nothing like that. Okay? It just takes these weird directions, a real soft release from the sun. So yeah, I mean, I really don't know what else to say about any of this because there's not a whole lot more to say. I mean, we could sit here and beat this to death if we wanted to. But I'm not going to. I've already showed you guys a bunch of different models. I don't think I'm not going to put a model update at the end of this video. But what we'll do is we'll look at the single take one here. Okay, this is the most current. Alright. Well, look at this, guys. I mean, seriously. I mean, come on, man. That's high. 713, that's pretty high. Okay? That's solar wind. Okay? You convert that, that's going to convert to over 1,000,000 miles an hour. And see, this is something else that's been going on here, right here. Look at the ion density. I think this is a mistake. I don't think this is actually the number. It's flatlined. There's no density there at all. But you can see the solar wind speed. You know how it's bouncing up and down here. Okay. But, again, now here's something I don't talk much about. This is the electric potential difference. Okay. Basically, it's kind of relating to how juiced our atmosphere is globally. So, you know, when you see this thing get real high and real erratic, you know, it's showing you the northern hemisphere and the southern hemisphere in two different colors there. So, when you start seeing like I don't know, massive lightning storms and stuff, a lot of times that electric potential difference will be going crazy. Okay, that's just been my observation. People don't really talk about that much because obviously it affects our local weather and stuff, but affecting space weather. I'm not sure how much it actually does affect that. Tell you what we're going to do. We're going to go over here to see to ISWA real quick. I'm going to pause it. All right, guys, I got these loaded up for you. I'm going to go ahead and just give you sort of an update on this real quick because it is still acting up. Okay. I did a little video earlier about this, but I'm going to show you again because look at this, guys. Okay, something is making our magnetopause react like this. Okay, and Scott mentioned in his live stream, and it's something I already knew, that, and I was saying it in my last video, that we're not seeing any evidence of any kind of energy coming from the sun. The tools aren't picking up any kind of CME stuff, coronal hole stuff. There's nothing showing on the tools to support our magnetopause acting like this. Okay, and I'll show you what I mean. Now, look at that, guys. I don't know that I've ever seen a signature like that. What would cause something like that? Well, let me tell you what would cause something like that. Our objects reacting with the sun, and this energy coming at us from the direction of the sun, because that's where our objects are at. Okay, it's coming from that direction, but I do believe that it has something to do with the reactions of the magnetic fields between our objects and the sun. So the energy gets shot this way. And like I was saying before, what concerns me about this kind of stuff, guys, is that we can get wave after wave after wave right behind each other, very close to each other. Now, I'm going to say something here that might help people understand a little bit. If anybody out there watches that show, Deadliest Catch, okay, it's where they do the crab fishing up towards Alaska in the Bering Sea, okay, anybody that watches that and has been watching it at all for any length of time knows that they go through some severe storms up there. Okay, winter storms, really high waves and wind. Okay, watch how they do their boats and how nervous they get when they get what's called stacking. Okay, stacking means waves stacking real close to each other, and they just keep coming. It's very, very dangerous, and it's very, very hard to predict, and it's also very, very hard on everything that's out there, right? So the same thing is happening here. We're getting wave, close to wave, back to back to back to back to back to back. Okay? Now, something else that I've started to notice here. Look at the color here. I haven't seen that deep blue color out in front of us like that for a very long time. Okay? There was one point where we're seeing like a dark, almost a black, a purple, and it lasted for like a month and a half, and nobody ever could figure out why. But it was mainly back here in our magnetopause behind the Earth. Okay, but what we're seeing here is we're getting waves of this. And I think it's because of the reaction that we're getting from these objects reacting with the sun. And it's traveling fast enough that it's getting here, and they're getting here back to back to back to back to back to back to back. And I don't think our shields have enough time to react and get back out in front of us before the other waves start hitting right behind it. So that would, in my mind, that would do two things. If we got hit with a wave, we were here the first wave. Well, we tried to push back out when we got to here, but then that second wave hit us. Well, now we don't just go back to here, we go back to here. Okay? And then, God forbid, a third one be right on its butt. We would rebound back out to here, and then we would get pushed way over here. I mean, that's what I'm saying. Plus, it would weaken us. Okay? The energy has to push away and push that other stuff away. So as it has to come back to itself. Basically, it has to right itself. Come back to neutral, however you want to call it. So it can protect us again. If it doesn't have time to do that, and some of that energy hits a weak spot, it's going to make it through. Okay? And, does that mean complete disaster? Of course not, guys. Okay? All I'm saying is that we might see satellite disruptions, those kinds of things. Okay? because it is getting very, very close to this dotted line, and that's the satellite line. All right. So as it keeps moving in here, guys, yeah. So just watch this. These are signatures that are very, very odd in shape and speed and intensity. Okay. Again, the Earth's acting like a capacitor. It's trying to push out in all directions. But it's easier for the energy to go behind us, okay, than it is to go in the front. Now look at that. Okay, this even kind of shows the hole I was talking about that can be created. Alright. So anything that made it past that first initial magnetic shield, the bow shock out there in the front, would have an easier road into where we're at. Right? Now our atmosphere will catch some of it. It'll get to the mantle. There's a whole lot of conversation there. And it can. The bottom line is it would increase earthquake risks, volcanic activity, all kinds of crazy stuff it could do. Now, sometimes it takes a while for the Earth to build that energy. Okay? So if we're getting hit like we are right now, and that energy is absorbed by the crust, the mantle, eventually that energy's got to be released. And how does it release? It releases in the form of an earthquake. And sometimes it takes it 2 to 3 days before it decides to let go. Okay? Now, there's a whole lot of angular connection that we can talk about. That's some big time conversation that, frankly, I don't think I'm qualified to talk about. You know, I can just say, hey, I think our earthquake risk is going up, and that's pretty much where my knowledge of this goes. I'm getting better. I'm starting to learn a little bit more about that. Been watching a lot of Dutch since, and Scott's been explaining a lot of stuff to me on the earthquake part of it. I am going to try to have him help me understand the phi angle and all that kind of thing, because I really do want to know about that. That's something that we look at, and I'll go over that a little bit later. But I do know that our earthquake risks are up when this happens. Okay, look at that. Okay, it's over and over and over again. I mean, look at this, guys. What is causing our shields to do this? That is inside. That is to the satellite line. That's what I'm trying to say. And this time when it did it, the satellite's right here. So, you know, when you see those kinds of things, you got to wonder that these things may end up going into safe mode and we won't get any data at all. That's one of the bigger problems that we have sometimes. Is when we're having an event, and if the satellite's in the way of trying to show us what the event's doing, if it's in the way and it's going to catch that energy, it gets shut down. Okay? That's what happens. Because they can't destroy it. Now this is what I'm talking about, path of least resistance. Watch this piece of energy peel off and go to the back. See that? You know, if it was, you know, equal all the way around, that may go towards the sun, but it doesn't, because it's easier for it to go that way. That's why it's releasing that direction. Okay? Now, we got energy, more energy. I mean, look at this. This is just some nutty stuff. Okay? Anyway, I wanted to show you guys that. I'll show you guys this other model real quick too, because this one, this is the magnetic lines, the IMF lines, and the closed and polar lines. So what we'll do, and this will show the wave action really good. See that we just keep getting hit. Even before one wave can make it off the screen, we're getting hit with another. I mean, look at that. That was like 3-4 waves right in a row. I mean, you know, a kindergartner can understand that this shouldn't be happening like this. Okay? They got to know that that's not good for us. No matter what. I mean, look at that. Wow. Woo-wee, that was a hit. Look at that. I'll be interested to see what the solar wind was on that one. But yeah, it wouldn't. Now, see, that is crazy right there. Nothing's going on right here, guys. Look. Everything kind of normaled out in the front, but watch this. Watch what happens back here. Did I go too far? Yeah, I think I did. Okay, there's those waves. They make it through. Everything kind of normals out. Now watch. Look at that. What was that? Nothing came from the front. What was that? Somebody please tell me. You know? And again, guys, when stuff is traveling magnetically, taking those highways instead of the typical solar wind highway, it can come in any direction. And it can do pretty much whatever it thinks it needs to. Again, path of least resistance. Okay, it's hard to predict when it's actually traveling that way. This is what I mean when we don't see nothing from the front. We cannot say it come from the sun. And that's what we all try to fall back to sometimes because it's the easier answer. Well, it's not about easy, okay? It's just about getting to what was actually going on. Now this shows this very, very well. Look, see the opening I've been talking about? Okay, it does close up sometimes, but it typically stays. Look at this. Okay, what I want you guys to do as you're kind of watching this model as I move it, keep a half an eye on that. That's the solar wind speed. Well, it's what they think is solar wind speed. This isn't solar wind. I'm just going to tell you that right now. Okay, but the detector doesn't know the difference. It can't tell you the source. It just knows that charged particles are hitting it at a speed. That's what it's detecting and getting put to us here. That was 1017. That was the one from earlier that I showed you guys. My earlier video. Okay. So, yeah. And it kind of calmed down there. That was a 700 I seen. Yep, 700. Now look. This is what I'm talking about right here. I want you guys to look out in the front. See the color of this? Watch, it's not even going to change. But then we see this ball of whatever shoot off. Where'd that come from? Okay, now you can see our bow shock moving, but is it moving because the energy in the back is pushing forward? Or is it something from the front pushing on it? It's kind of waving, but where did that big ball come from? Shape of a ball, I should say. That's a magnetic shape of a ball, all that is. It's not some big, huge object or anything. It's just magnetics there. Solar wind, okay? Now, again, guys, it seems as though it might be calming down a little bit, but it did get up to 7 again, almost 8. And what I'm going to show you guys here real quick before I let you guys get out of here, I'm going to take you over to space weather real quick, and I showed you guys this earlier. They're not predicting anything, okay? I mean, the solar wind says it's 453 right now, right there, okay? If we go down here and look at the geomagnetic storm activity, nothing's there, but our magnetopause is going crazy. Okay, now it can do that. We don't have to have a geomagnetic storm for our magnetopause to take hits. That's not what I'm saying. All I'm saying is that is not what's going on. So, looking at the speed here, see, this is where I start having issues. Remember I talked about these dots? That's just one data point where the speed just kind of spiked a little bit. All right, so that was pretty high. That's probably where that 1017 I seen, 1017. Okay, that's probably when that happened. But, what about these other ones? Maybe there were little spikes, but as you can see, typically they're showing the solar wind speed is not even getting up to 500. But yet we're seeing readings saying, to the contrary. Now, right now, it's the 14th. Okay, we're into the 14th, which is right here. Okay, the conditions at Earth are the green lines, and I've explained this a lot. But you can tell that they're not predicting any massive increase in solar wind speed or any big, big time stuff going on with the density. So why is our magnetopause reacting? Well, it's because of our objects reacting with the sun, and that's how the energy is getting here, guys. That's what's going on, okay? It's pretty much what, that's the way I understand it, and that's kind of what my research is leading me to think. And again, there's the KP again. There's nothing there. It's not showing anything. So why are we seeing these crazy signatures, right? Now I'm gonna show you one more model, because I showed you the ISWA magnetosphere models. I'm gonna show you this other one, okay? This is the one from NOAA. All right, just to show you that it ain't just one model doing this. It's all of them. Okay, I mean, that obviously you're going to see some waves here, and it is quiet. It seems as though it might be quieting down, because probably what's happening, guys, our objects are starting to move away from the sun a little bit, because it's been 24 hours since we got the first bigger one sighted, the first big one. Okay, and the second one wasn't far behind the one that I seen. So we're looking at multiple hours. So it may be far enough away from the sun that it's not reacting as much right now. Okay, that could be what's going on. All I know is, especially when you see this thing go all white, you know what that means? If you look at the key here, that means it's really, really low density everywhere. And that's not good either. Okay? I mean, obviously you can see waves. I've got video of some stuff here that I could show you real quick. Let's see if I can do that. I don't know if I can, guys. I got it in this the same program that I use to record here. But anyway, guys, this has been a long enough video. I hope you guys get something from this. I just wanted to bring that to you and show you that, hey, we did catch a second object. I do believe that it's one of the ones that's traveling with it, with the one that Scott caught. Okay, but it is a different object. All right. So anyway, guys, I may put an update on the back here with some music or something. I'm not sure yet. I may just show a couple different graphs and stuff. But God bless. Yeshua saves, and you can drink this Kool-Aid.